Okay, so I work at the Tyndall Centre for Climate Change Research, and I specialise in the economic aspects of environmental sustainability. I'm an economist by background. I look at things like techno-economic feasibility, business models, but in general I'm interested in interactions and conflicts and frictions between areas of research, for example, environmental sustainability and economic sustainability. And so that was part of my motivation for doing this work, looking at the frictions and synergies between digital security and sustainability. So in this talk I'll use digital security interchangeably with cyber security, and by sustainability I understand here environmental sustainability primarily, which is my area of expertise. This work came from a briefing I did for the National Cybersecurity Centre and another government agency that shall not be named. So that's what underlies the work. So it's pitched at the civil servant level. It's not very technical. So context. So what do we know about these two areas of expertise? So data science obviously provides a very powerful tool for facilitating low carbon economy, and digital twinning is one example for the energy system, but it can also consume large amounts of energy. So think about data centers, how much cooling they need, very energy hungry, and we already know of cases when they are overloading the grid, especially when the weather is really warm. So that sort of interacts with the climate change and issues at the environmental level. Increasingly, energy systems and other systems are becoming more digitized. They have online modes, so digital twinning again is an example. But that creates more digital exposure to cyber attacks. On the other hand, so from this different direction, we've got climate change impacts. So we're clearly not mitigating climate change enough, so not reducing emissions fast enough to avoid climate change impacts. And that's exposing our physical infrastructure to other risks. Extreme weather events is one example. Extreme temperatures, for example. So there are interactions between these areas, clearly. And some of these interactions are aggravating the risks, while other interactions are more synergistic, so we can look at some co-benefits. I think it's difficult to think of two issues that are going to affect us personally and our economies in more negative ways, actually, than cyber attacks and climate change. And there are various amounts, various estimates that are put on how much it costs to cope with cyber attacks. So, for example, we know that in 2017, that figure was, annual global figure was just below $1 trillion US, so it's a lot. But actually it's projected to increase by the end of this decade to up to $14 trillion, and that's per year and globally. So it's really large numbers, trillions of dollars. When we think about the global cost of climate change, the numbers are still in the billions of dollars, but I think we've not got long to wait before that will tip into trillions as well. So for example, in 2022, the climate change cost globally was around 300 billion. And for the UK alone, the climate change cost so far is about 1% of GDP per year. But by 2050, it's predicted to reach about 3% of GDP per year. And that's for the UK. And by the end of the century, it could reach up to 7% of GDP. So it's quite a lot, and that's with current climate change policies. So I'm not saying that we're doing nothing here. So if these two problems come together, I mean, it's going to cost us quite a lot. So there is good motivation to looking at how they might interact and aggravate each other. So some of the research trends at the intersections. Yeah, the formatting is a bit fun, but anyway. So mainly research focus has been on smart grids and smart cities in this area, and that's not to say that there is not research going on separately, trying to make ICT infrastructures more sustainable, for example, or trying to apply ICT to sustainability. But if you look at the intersection and co-benefits, there are very few papers actually, there's not so much research. The research on smart cities in particular overlaps quite a bit with research on electric vehicles and autonomous vehicles. So that's an area that's a lot more explored. In terms of smart cities, some of the areas that are looked at is privacy, cyber-physical infrastructures, safety, security of critical infrastructures. But that's again limited to cities, while there are gaps in things like cross-border infrastructures, for example, transmission lines. Research outlets here are mainly conference proceedings or journals that don't have very much citation impact. So partly because it's a small area of research and partly because it's quite underdeveloped. The papers are mainly conceptual. So they're looking at what terms mean, define what this means, and what, lost my train of thought there. Anyway, so there are a few empirical studies. So one I have found is actually based on transport and might not hold for other sectors. In terms of disciplines, it's dominated quite a bit by computer science, a bit less by environmental science, but the main thing is that those two groups should really work together to address this area. So some of the similarities between cybersecurity and environmental sustainability. So both of these are part of the global commons, such as the deep seabed and the atmosphere or outer space. And so they suffer from some common problems, for example, difficulties of enforcement, collective inaction, free riders, dispersed benefits, and often concentrated costs. So these are some of the issues. They have important differences as well, and I guess this is arguable, but digital security is seen as a means to an end, while sustainability, like prosperity and well-being, is that end, so something that we're using other things for. So when we decide whether we want to upgrade infrastructures, for example, what should we prioritize? That's the question. Because we know that upgrading is good for cybersecurity. Change your phone every couple of years or your laptop. You're advised to do that if you're a civil servant, for example, for cybersecurity reasons. But in terms of waste that generates, it's quite significant. And that's kind of toxic waste that we don't want, waste from batteries. So what should be prioritized? Some of the risks here. So in terms of infrastructures, where critical infrastructures are concerned, for example, transmission lines, pipelines. For now, it's natural gas pipelines. In the future, might be hydrogen pipelines or even CO2 pipelines if we want to ship that away to where CO2 will be stored. Where this infrastructure crosses borders, there's often an unwillingness to cooperate among governments and other actors. And current legal frameworks are always just trying to catch up with issues. We know that's true in cybersecurity and in climate change as well, because things that we're doing with climate change in terms of legal frameworks are not sufficient to where we want to do. And so I don't want to finish on a problem only, so looking at some of the synergies and then solutions. So decentralized nature of many sustainability measures is hopefully going to help with cybersecurity because of the redundancy. So there would be no single point of failure in that sense. And decentralized nature is good in many ways. For example, good for innovation, good for experimentation, good for empowerment of local actors. But it also has issues. So there is no single decision point. There is no hierarchy. So often this dispersed nature is increasing the risk. Then there is a study that actually looked at components of cybersecurity, 6 components, and the first 3, like control, integrity, and authenticity, were positively correlated with sustainability. So if you increase one, it's good for both sustainability and cybersecurity, while the other 3 had no impact. But that's a study on transport, so it might not hold for others. So in terms of solutions, underpinning some of the technical solutions like network and data and device security, conceptually, it might be useful to draw on the concept of resilience because it incorporates partly both sustainability and cybersecurity, so it might be worth talking in those terms. And actually some experts already say that the word sustainability will be overridden eventually, and the concept of resilience is a lot more inclusive in that sense. And what can they learn from each other? So One is, so from sustainability side, polluter pays principle is very common in this area. So you tax polluter, for example, or you wind down those polluting industries. So cybersecurity might learn something from that area. And the opposite way, the cybersecurity has quite a bit of success with non-state actors, and I think that could link to sustainability as well to help with implementing those climate change measures at a distributed level. All right, so that's it from me. Any questions?
Thanks, Maria. Any questions from the audience? No?
Yeah.
Okay.
Cybersecurity is much of a buzzword as artificial intelligence is at the moment. But yeah, there seems to be a lot more money being spent on cybersecurity than there is in protecting our environment. I think that priority is wrong. We need to protect the Earth more than just our data on our systems, but that's just because you're talking about real, like you distinguish the two sets. But I'm just wondering where this is heading. Is there going to be more of a synergy between environmental science and cybersecurity, or is it just going to continue that it's going to cost more and more money, basically? There's got to be some sort of tipping point where we've got to look after the Earth, and everyone's got to look at it, share the data that is needed for it.
Yeah, I think the key word is tipping point. So although more and more money is invested in cybersecurity, although some people will say it's not enough, and climate change, they sort of moved in parallel. But as we are not investing enough in mitigating climate change, I think what we'll see is more and more climate impact, and so that's going to tip us into action.
You get to a point where we can't terraform the Earth back to what it was, then we're all going to have to go to Mars.
Yes, exactly. So looking at behavioural research in this area, it's not looking very optimistic, I think. So we do prioritise often short-term gains over longer-term positives, and so if something is going to inflict pain on us, it might mean that we might not act in the short term. So, for example, if you look at some surveys about net zero, people are generally supportive. So I think about 3/4 of respondents are generally supportive. But as soon as you mention costs, and that they might have to bear some cost, the support for net zero drops to around 15%. And it's understandable, so it's human nature. But I think the climate change impact events are going to tip us into action eventually. It's just that it might take a bit of time.
Okay.
All right.
It's time to
Thanks.
move on to the next speaker. Thanks, Maria, again.